Okay, so let's see if we can use this wrapping function to help us determine the value of each of the following functions. Well, pi over 6, we happen to know what this one does, right? If we were to look for our wrapping function, let me get a pen going here. If we happen to be looking for the wrapping function of pi over 6, as we just did in our previous video, then what we would have found is that we would have had the coordinate point radical 3 over 2. That's supposed to be a radical 3 over 2 comma 1/2. And since the y-coordinate from our wrapping function is associated with the sine, then what we're really saying here is that the sine of pi over 6 then is equal to the wrapping function's y-coordinate at pi over 6. That is 1/2. So what our real task right here would be to figure out, well, what does it mean if we said something like 11 pi over 6 or negative 11 pi over 6? Well, what does the negative mean in the first place? That negative really means that we have a function that has, let me get my x and y axis going right here. That means in standard position we've rotated in the counterclockwise position, right? The clockwise direction, right? And we said negative 11 pi over 6. Well, negative 11 pi over 6. That means that as we're looking at our rotation, we're going in the negative direction. Here's negative pi over 2. Here's negative pi. Here is negative 3 pi over 2. Negative 11 pi over 6 would be all the way over here, right? Negative 11 pi over 6. Negative 11 pi over 6, that arc length is associated with an arc length in standard position of pi over 6. Why? Well, let's think about where 11 pi over 6 leaves off. If we were to take negative 11 pi over 6 and add to it the angle 2 pi, right, one full rotation, this is actually negative 11 pi over 6 plus 12 pi over 6. That's positive pi over 6. And this would be coterminal. And so in effect, what we've done is we've just repeated ourselves from the previous problem right here. And if we say cosine of negative pi over 6, our answer right here should be positive radical 3 over 2, because we're taking the coordinate point that's formed right here associated with that pi over 6 arc length. All right, so let's take on ones that aren't as easily identified. What about negative 5 pi over 3? Well, again, I think the best way to do this is to take our angle and find a coterminal angle between 0 and 2 pi and figure out what that is. Negative 5 pi over 3, if we added 2 pi to this angle, is going to be, let's see, this is 6 pi over 3, so this is actually pi over 3. We know that pi over 3 is actually located over here in this first quadrant. And so pi over 3, we said that our wrapping function for pi over 3, as we showed in the last video, is the cosine of pi over 3 as our x-coordinate, and the sine of pi over 3 as our y-coordinate, radical 3 over 2, pardon me. And so if we were to take these two, we're actually finding the tangent of pi over 3. Well, we actually already know that one if we've done our job. We're just talking about radical 3 over 1. Right? Well, as a note aside, if we wanted to, we could take radical 3 over 2, the y-coordinate divided by 1/2, which is the x-coordinate, right? Remember, it's y over x. And we would end up with radical 3 over 2 as the result. So it is the same thing. Okay, cosecant of 7 pi over 6. Now we're in a little bit of a different situation right here. Cosecant of 7 pi over 6. Well, we have to ask ourselves, where does 7 pi over 6 leave us? Well, if we're in standard position, 7 pi over 6. Let me get another circle right here. 7 pi over 6, if we're interested in looking at where that's at, we might look at these principal positions to help us judge. And I always go to pi because, well, pi is an easy one to do. And pi is equal to 6 pi over 6, right? So it's 6 pi over 6. 7 pi over 6 is 1 pi over 6 greater than that. So it's almost as though we're taking a position in our unit circle that corresponds to the reference angle of pi over 6. And we know what happens at our reference angle of pi over 6. So 7 pi over 6 goes with that pi over 6 angle located in the third quadrant, 7 pi over 6. So for that arc length, what would our wrapping function be? Well, it would be equivalent to what we would get for pi over 6, except now that we are in quadrant 3, that means our x-coordinate is negative, so negative root 3 over 2 for our x-coordinate, and of course our y-coordinate is negative, so that's negative 1/2. Cosecant, right, our hypotenuse is 1. Cosecant is 1 over the opposite side, which is our y value, right? So we said this is 1 over y right here. And so we would treat this as 1 divided by negative 1/2, which we know simplifies to be negative 2. And so that's our answer. Our cosecant of 7 pi over 6 would be negative 2. All right, we'll use these facts as we keep going through the section. More to come.